Hello students, in this session we'll discuss about the difference between galvanic cell and an electrolytic cell. We'll go through Faraday's laws of electrolysis. We'll try to understand the concept of equivalent weight, and also we'll do some of the problem based on this. What is the difference between a galvanic cell and an electrolytic cell? A galvanic cell converts chemical energy into electrical energy, whereas an electrolytic cell converts electrical energy into chemical energy. The reaction that takes place in a galvanic cell is spontaneous, whereas in an electrolytic cell, the reaction is non-spontaneous. In a galvanic cell, the electricity is produced, whereas in electrolytic cell, the electrical energy is consumed. To set up a galvanic cell, two half cell in different container is needed. If it is not in a different container, then a porous partition is used to separate them. Therefore, two cells are needed, which is either connected by a salt bridge or a porous partition, whereas in case of electrolytic cell, both electrodes are placed in the same container. That is, only one container is needed. In a galvanic cell, anode is negative and cathode is positive, whereas in an electrolytic cell, anode is positive and cathode is negative. You should also remember that in both galvanic cell as well as electrolytic cell, at anode, oxidation takes place and at cathode, reduction takes place. You can see the pictorial representation of electrochemical cell and electrolytic cell. As we have mentioned, the electrochemical cell, the two half cells are in two different containers, which is connected through a salt bridge, whereas an electrolytic cell is set up in a same container. Both anode and cathode are in the same container. If you look into the polarity, in the case of electrochemical cell, you will see that the anode is negatively charged and the cathode is positively charged. Whereas in the electrolytic cell, the opposite is the case. The anode is positively charged and cathode is negatively charged. And you can also see that in both electrochemical cell and electrolytic cell, at anode, oxidation takes place and at cathode, reduction takes place. Now let us discuss about Faraday's first law of electrolysis. According to Faraday's first law of electrolysis, the amount of substance liberated or deposited at the electrode is directly proportional to quantity of electricity passed. The amount of substance liberated or deposited at the electrode is directly proportional to the quantity of electricity passed. Now, mathematically, if W is the amount of substance deposited or liberated, then W is directly proportional to Q, where Q is the quantity of electricity. The unit of Q is Faraday. The Q is equal to current into time. The current is in amperes and time is in seconds. Now, if you write the equation for it, then it will be W is equal to ZIT, where Z is the proportionality constant. This proportionality constant is also known as electrochemical equivalent. Now, how to define electrochemical equivalent? Electrochemical equivalent can be defined as the amount of substance deposited or liberated when a current of 1 ampere is passed for 1 second. Or you can say that the amount of substance deposited or liberated when 1 coulomb of electricity is passed. That is it. Faraday's second law of electrolysis. For that we have taken 3 solutions: copper sulfate, silver nitrate and aluminum chloride, and they are connected in series so that same amount of electricity flows through these 3 solutions. According to Faraday's second law of electrolysis, if same amount of electricity is passed through different solution connected in series, then the amount of substance deposited or liberated at different electrodes will be directly proportional to their equivalent masses. If same amount of electricity is passed through different solution connected in series, then the amount of substance deposited or liberated at different electrode will be directly proportional to their equivalent masses. Mathematically, the weight of substance deposited will be directly proportional to their equivalent mass. Now, what is equivalent mass? In order to understand equivalent mass, we should know what is a Faraday. The quantity of electricity carried by 1 mole of electron is known as a Faraday. So, the value of a Faraday can be calculated by multiplying 6.023 into 10 raised to 23 with that of the charge of electron, which comes to about 96500 coulombs. So, what is an equivalent weight? It is the amount of substance deposited or liberated when 1 Faraday of electricity is passed. Now we'll understand this concept in greater details in the next slide. Now from the equation, it's very clear that in order to deposit 1 atom of copper, 2 electrons is needed. So in order to deposit 1 mole of copper, 2 moles of electron will be needed, which is equivalent to 2 Faraday. Going by the same logic, you can see that in order to deposit 1 mole of silver, you will need 1 Faraday, and in order to deposit 1 mole of aluminum, you will require 3 Faraday. And you know that quantity of electricity carried by 1 mole of electron is equal to 1 Faraday. And the amount of substance deposited when 1 Faraday of electricity passed is called the equivalent weight of the substance. Therefore, if you look into the equivalent mass of the copper, it will be atomic mass of the copper divided by 2. Whereas for silver, the equivalent mass of the silver will be equal to its atomic mass. Whereas in case of aluminium, the equivalent mass of aluminium will be equal to the atomic mass divided by 3. Therefore, we can say that equivalent mass of an atom will be equal to the atomic mass divided by its oxidation state. The question is how much charge is required for the reduction of 1 mole of Cu2 plus 2 Cu, 1 mole of Al3 plus 2 Al, and 1 mole of MnO4 minus 2 Mn2 plus. The answer is quite simple. In case of copper, 2 moles of electron is needed, therefore 2 Faraday of charge is needed. Since the oxidation state of aluminum is Al3 plus, therefore 3 moles of electron will be needed, which is equivalent to 3 Faraday. In case of reduction of MnO4 minus to Mn2 plus, 5 electrons are involved, therefore 5 Faraday of charge is needed for this reduction to happen. How much electricity is required to produce 20 gram of calcium from calcium chloride, 40 grams of aluminum from molten Al2O3? We know that for 1 mole of calcium, 2 Faraday is needed. Hence for 20 grams, it's quite simple because it is half of its molecular mass. So 1 Faraday, 20 grams of calcium means equivalent mass of calcium. In case of aluminum, we know that for 1 mole of aluminum, 3 Faraday is needed. So 3 Faraday will deposit 27 grams of aluminum. So in order to deposit 40 grams of aluminum, you can simply calculate like this. Okay. If a current of 0.5 ampere is passed through a metallic wire for 2 hours, then how many electrons flows through the wire? Since quantity of electricity passed is equal to current into time in seconds, we can calculate the quantity. This comes around about 3600 coulombs. When 1 Faraday of electricity is passed, then the number of electrons is equal to 6.022 into 10 raised to 23, because 1 Faraday is the amount of electricity carried by 1 mole of electron. From this we can calculate the amount of the number of electrons when 3600 coulombs of electricity is passed. Okay. Now the question is, two electrolytic cell containing silver nitrate solution and copper sulfate are connected in series. A steady current of 3 ampere is passed through them till 1.078 grams of silver is deposited. How long did the current flow and what weight of copper will get deposited? Here the atomic mass of silver and copper is given. We know that to deposit 1 mole of silver, 1 Faraday of electricity is needed. To deposit 1.078 grams of silver, 965 coulombs of electricity will be needed. Hence, the quantity of electricity passed is 965 coulombs. Since quantity of electricity passed is equal to I into T, so we can write 965 is equal to 3 into T. So the T comes out to be, that is time in seconds, comes out to be 321.66. So that much amount of time the current flows. And since in order to deposit 1 mole of copper, 2 Faraday of electricity is needed. That is 2 into 96500 coulombs will deposit 63.5 grams of copper. So 965 coulombs will deposit 63.5 divided by 2 into 96500 coulombs into 965. This comes out to be 0.3175 grams of copper.